All right, so how do I set up the Munskin? Here's one little thing to be careful about. If you want to factor something out, you have to, if anything, for example, you don't have to do this, but if I can take an e to the x out of the first row, correct? And I could also take an e to the x out of the second row, which means I'd actually take out an e to the 2x. Right? If I multiply either row by something, that's going to directly affect the determinant because each of these are involved in each of the pieces. Does that make any sense? So, yes. But there's no need to do that. You don't have to do that. So screw that. Don't memorize that. What's the determinant here? E that, I like it. 3e to the 4x minus e to the 4x. E to the 4x, I like it. So sure enough, you get something that not only, well, it's never zero, right? So if you get something that could be zero, it's not a problem, because you just need it to not be zero somewhere. Okay, is everybody with me so far? All right, so this determinant can't come out to be 0, so this is good. But did you have a weirder one? Okay. All right.
Quite literally, I just
Say again?
Can you do the
Bigger one, okay. Do a 5 by 5. Hey guys, we don't want to learn anything new today. All right. Just make them do an 8 by 8. No, I don't want to. No. What goes here? And then keep going now. I'll do this one. Right? So the shortcut is to redo the first and second. Right?
Yeah. Yes, I concur.
Okay. Oh, something's broken. You concur. I concur. E to the x, e to the x, e to the x, e to the 3x, 3e to the 3x, and then 9e to the 3x, and then where do I go from here? So if I do these, I'll get 48, right? 48 e to the 8x, and then here I'm going to get, oops, here. I'm going to get 4 e to the 8x. What happened over there? Where am I at? So here, here, here. Like it. And now I do my negative ones, right? So if I go this way, I'll get minus 3e to the 8. And then I'll get, let's see, where am I at? Here, yeah. Oh, sorry, minus 36 e to the 8x. So these are all my negative ones, right? And then I get minus 16. So then you get 5261 minus stuff. Minus 3 is 58. Minus 36 is 1480. Minus 68, negative 2, I think. I did it fast. Okay. That's the shortcut to doing the, taking something and expanding it around and doing the determinants of the little matrices. I don't know if a lot of you guys,
Wouldn't the other way be easier than this one?
I kind of feel so, but I always know students like this for some reason.
Oh.
Yeah, it's less stuff you have to set up yourself. Yeah. You just repeat, and they go bam, 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 bam. There's a lot of things that students like the shortcut, and I like the longer way, which, so it's good to hear somebody else agree with me sometimes. It doesn't happen very often. Okay. Is that all right? Yeah. Anything else? No. The beautiful thing about matrices is, I don't care how big this gets, the process doesn't really grow as quickly. So if you wrote the associated, so if you have a matrix that's trying to solve a system of equations, if I add one more equation in and one more unknown, doing that by hand becomes crazy long. The matrix barely grows the amount of work. You guys kind of with me? So matrices, students hate them when they first learn them because they're first learning them. But once they kind of get to know them a little better, they realize, oh, it's a game, right? For us, not so much a game. I'm sorry, but the important thing here is I got something that's not 0. Okay. Okay, so anything else? Any other topics? Yes.
I feel like I created a new form of factoring with the last equation.
I like it. What you got? Do you remember what you had?
Yeah, so the 54th, I ended up throwing on the opposite side of the equation.
So besides the
Okay. And then I took out an M. It just felt weird. I haven't really done factoring like that.
Oh shit! All right,
it's like
that's not gonna work.
It's not gonna work.
I don't know. I'll take a look. Who knows? You might have been.
I don't think it worked.
I don't think it's gonna work.
Yeah.
I just like, why do you think
I love you guys so much. You all know that you could get a problem that requires synthetic division, which is why we kind of covered synthetic. No. This did not require synthetic. I'm just saying, guys.
I tried to do it.
I am just saying that is where it could go. I didn't go there. I went to a grouping problem. Oh. Come on. So again, just reminding guys, we're gonna have a few situations. In 4-7, we're gonna have it again, where you just have to remember how to factor shit. Right? So if you have 4 or more terms, you try grouping. And if grouping doesn't work, then you have to try synthetic division, right? So I just gave you one that only needed grouping. Could you use synthetic division? Hell yeah, shit yeah. Synthetic works all the damn time. Right? You just have to guess right.
Yeah, I started that.
You have to be lucky. So I don't know what stats you picked at the beginning of your life. My luck stat is really low. So I don't play cards. I just guess. Okay. I want to do, if nobody's got any other specific questions, I want to do an example of reduction of order. Using the full-blown thing and show you the difference between that and the shortcut. It's kind of related to what somebody just asked me earlier. So let's do this. And then we're going to get into section 4.6, which I kind of warned you about before. The name could sound kind of daunting, variation of parameters. But it's so cool. And I don't know if that makes you feel good or bad when I say something's cool. Right? You guys are like, this guy likes it. Shit. Okay. So here, let me put this up here. What do you got? Okay. I'm going to go ahead and tell you that one answer is, so you're not going to have to solve this. So this is kind of like from section 4.2, so we officially didn't know 4.3 yet. But I don't know if you guys can realize this would have a repeated root if you make the associated, not the auxiliary equation. You guys with me? Because this would be, if that was a minus, that would be perfect squares, right? And so 3 times 2 plus 3 times 2 is 12. So whenever you see that, you know it's going to be something squared. You're going to have a repeated root. Are you guys kind of with me? So even if we did the auxiliary, we would just get that one answer. That's all we would get, right? Or a little less. And that's bad, of course. All of you guys know this by now, because how many answers am I supposed to get? Freaking 2. Yeah. So I should need to use C1 and C2 because it's a second order. That kicks so much ass. It's just like the fundamental theorem of algebra, right? Does everybody remember that one? No? That's the one that says whatever the degree of the polynomial, if it's equal to 0, you have that many answers. Some could be repeated, that's fine in algebra, but you get that many answers. So you guys kind of with me? F-TOA instead of F-TOC. Not the fundamental theorem of calculus, but the fundamental theorem of algebra. All right, all that aside. What's the first step if I want to use full-blown reduction of order? Roo! How do I, yeah, what do I assume? Yeah. I assume YP is, not YP, but Y is UY1, which was the first question on the quiz, right? And of course, I assume that because I know, this is gonna be huge today. I assume that because I know whatever other answer there is has to be linearly independent, or else it really isn't another answer. It would just go with the one I already got and still only have one answer. Does that make complete sense? Okay. So what's y prime? Oh, let me do this. Let's get more specific. So y equals u e to the 2x over 3. What's y prime? U prime. Let's do that. Yeah. Sorry, I hear you. Plus, you're good.
You got
2 over 3, u e to the 2x.
Okay, I like it. Just write it the same way you do. Okay. Not so bad, all right? Something's gonna happen right now that's gonna happen a lot. So I wanna make sure you guys see this. So if I do y double prime, it'll be u double prime, e to the 2x over 3. Each of these is gonna be a product rule, right? Okay. So you're like, thank God this wasn't a fifth order. The next thing I'm gonna do is I'm gonna do the derivative of this. So I'm gonna get 2/3, isn't that the same thing as this? I'm gonna get 2/3 u prime. So the first thing we're gonna do here is get a u prime. I don't know if you guys are with me. So I can just do, see if you guys are cool with this. I'm gonna get 2/3 this plus 2/3 same thing. So I'm gonna get 4/3 u prime e to the 2x over 3. And then I just need to do the next thing here, which would be a 2/3 comes down, makes it 4/9. If you don't like that, just don't do the shortcut. Just put it all the way out there. Is everybody with me so far? This is why I actually prefer the long way here, because you actually put eyes on what's going on. Okay, so now I can put all this stuff in here. I get 9, where am I at? Here. Oh, by the way, real quick, here's another quick thing. Every damn thing I'm about to put in here, every single term has what in it? And can that ever be 0? No, so then I can divide by it. I'm not gonna write any of them down. Oh, holy shit. I'm gonna write all that crap. Is everybody with me?
Yes.
So this is a continuing thread throughout all my classes. I'm trying to tell students, be nice to yourself. The math is already mean, can be. So be nice to yourself. I'm not gonna write it's gonna cancel out. So I'm just gonna do 9 u double prime. What's 9 times 4/3? 12 u prime. And then what's 9 times 4/9? 4. Is that cool? Just not writing the e to the stuff. Okay, I like it. Minus 12 times y prime, so I get minus 12 u prime minus 8 u. Is that cool? Okay, you don't have to, unless you want to. Sound effects help, they do. And then I get plus 4 u, because I'm not going to write this guy. Is everybody really okay with what just happened? Yeah, you're really okay. Okay. Don't lie to me. Okay. It's bad to lie to me. I'm the only one that can help. So look what happens. For these, the same thing always happens for the e stuff, for the constant coefficient, blah, 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 blah. What do I get here? I get 9 u prime, double prime. There's no other u double primes. Right? What happens here? Cancels. What happens to all this business?
Cancel.
Cancels. Yeah, get out of here. Is that right? Will that always happen with reduction of order? Hell no. Will that always happen for this kind of situation? Yeah, and this is going to lead to why the shortcut is throw an X on the damn thing, right? That's just a shortcut. Divide by 9, get out of here. Integrate once, what do you get? I'm going to call it C1. It's crazy. Everybody with me? Is that cool? And that kicks so much ass, right? Everything canceled except, so I can just directly integrate. I'm not used to that. It's not really a DE. It's just, I just had to integrate twice. So then U would be, integrate one more time. Everybody with me? Okay. We're going to follow this up with the shortcut and see what the shortcut does. So therefore, my assumption was that, so y will equal u times y1. So I'm going to get c1x times y1 plus c2 times y1. Do you see how that gave me the complete answer? Stay with me now. All right. I'm gonna erase the roux stuff because I don't need it anymore. But underneath here, I want to do the shortcut. So who prefers the shortcut method? Anybody? All right. So tell me what it is.
It's y1 times the integral of.
Hold on. Sorry. I'm actually asking you because I always forget.
E to the negative
yeah.
x over y1 squared.
Good. I love it. Need some new erasers. All right, so y2 is going to equal e to the 2x over 3 times the integral of e to the integral of, what's p? Be careful. What, negative 12 over 9, right? Yeah, negative 4 over 3. So this would be 4/3 x. Is that cool? I'm going to integrate negative 4/3. So I'm going to get 4/3 x. Yeah. And then it's going to be over y1 squared, which is, and of course that's just 1 coming next. So then I get y2 equals x e to the 2x over 3. Now notice that is not the complete answer. That is the second answer, and then you have to construct it. Here you get the whole thing, right? I'm not saying that's some selling point to do it this way. I'm just saying when you do it with the shortcut method, you just get the second answer. You still have to put it together. Don't circle this shit and keep going because you haven't told me what the answer is yet, right? The answer is a collection to make a fundamental set of solutions, yes.
So when you divided e to the 2x over 3, is that the same as like factoring? Factoring it out, I mean?
Oh yeah,
Bring it
totally.
back in.
Yeah, I factored it out, every piece, and then I divided both sides by it because it can't be 0, so I'm allowed to. Okay, cool. You guys all with me? So there's the shortcut if you want to memorize that, or you can do it this way if you want to, either way. Yeah.
I swear I remember the homework where the reduction of order one, the one on the left, would work while the formula would not work. I swear that happens once.
You'll have to show me.
Okay.
Yeah, so if you could find it.
Should I do it right now?
No. Alright, sorry. But please do, or if you find which problem it is, just email it to me. I'll try it out and I'll tell you if I get something weird too.
Okay.
But that should always work because it's just, that is just a collection of what this does. So if this works, that must work. So you must have made a mistake over there. Yeah, maybe. Well, you know, I found a hole in your differential equations, Jeff. Oh, shit. Damn. Let's write a paper. All right. Everybody with me on that? Okay, now, I've got to stop using purple. Good Lord. Also, these suck. This is equivalent to like banging the chalkboard. Yeah, anybody remember that? Did you ever do that? You're so excited to get to pick that, and you're like destroying your lungs with all that. You're a kid, you're healthy. Go bang these erasers. You're too healthy, kid. Get out. Alright, I am not going to use purple. I'm going to spray in a minute. Not now, I'm going to spray later. Okay. Yeah, you're purple. Alright, so I want to do this. So can you guys help me out? I'm an old man who needs some help. Oops, let me make this a little more interesting. Yeah, there. Sorry? Not yet. What do you do first? And there's a really, really specific reason why you must do this first. What do we do first?
Associated homogeneous.
Yeah, so that's called the what? Set up the ah. I thought you guys might have fun with that. Ah. So what's the ah? Associated homogeneous. We're just going to call it ah, right? If you don't like that, too bad, because it's been done. Associated homogeneous would just be this equal to 0, this one makes it homogeneous. Right, so and by this point I think you should all understand, I've said it enough times, if I find everything that makes it 0, and then I find yp, and add the 0 shit, it's not going to screw up my yp, dude. It's going to still be able to do what it's supposed to do. You're okay. What's the auxiliary? M squared minus 2m. I forgot my little y dude there.
Minus 3.
I forgot my little y dude there, sorry. By the way, real quick. If there was no y there, you'd have to add it over, and that would be part of the g of x, right? Then here you get, screw it. Yeah, well, I mean, what do you get?
M minus 3 times M plus 1.
M minus 3, m plus 1. So then I get, can you guys just jump to this?
Y equals C1 times e to the 3x plus C2 times e to the negative.
Beautiful. Now, can you identify an issue with the next step? Any constant multiple of either one of these makes this 0, correct? What would my assumption be if I didn't know that for yp? My assumption would be a e to the 3x, yes? Yeah. Now we know that's wrong. Can't possibly work. Do you all understand the issue here? So pretty cool with that. That would be what I would guess. And in fact, that's why you do this first. Because if you do this and try to solve it, it ain't gonna go anywhere. It's gonna go to weird places. You're gonna be like, I don't know what I'm doing, because you should have done this damn thing first, right? Is everybody cool with the fact that there is a problem here? Okay, I like it. And you're like, yes, you wrote a problem down. But I mean, within the problem, I cannot have a constant multiple of e to the 3x as a possible thing to make this happen, because they will all make it 0. None of them will make it e to the 3x. Cool. So then what do I assume instead? Yeah. And of course, where does that come from? That was part of the question on the, where does that kind of idea come from? Like a reduction of order idea. Okay. Today we're actually going to see a broader idea that relates to this. In fact, maybe I'll do this one again. I don't know. This could get gross. All right, Jeff, don't do this one. So now what do I do? I'm going to do derivative, right? So, because I want to throw all this stuff in there. So what's the derivative?
3 to 3x plus 3ax e to 3x.
Good. And then I'm going to do what? Double prime.
And then you get 3a to the 3x.
3a e to the 3x. Plus another 3a e to the 3x. Is that cool?
Yeah. You got that one.
Plus 9ax e to the 3x. I don't know if you guys are understanding. It doesn't matter. It's not that big of a shortcut. But does everybody see where I got that 6 from? Derivative of this will be 3a blah 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 plus, if I take the derivative, I get another 3a e to the 3x. So I get 6. It's crazy. Okay. And now I throw all this stuff in. Right? So I get 6a e to the 3x plus 9ax e to the 3x minus double this dude. Minus triple this dude. Where'd it go? There it is. I could have just not written the freaking e to the 3x. Too bad for me. Oh, equals, not 0, but equals e to the 3x. Now thankfully, notice what happens. What about all my x terms? Cancel. So then I get 4a e to the 3x equals e to the 3x, so then what's a? I feel like I want something, but I'm just going for it. A would be 1/4. Is that cool? Alright. So then I know y equals c1 e to the 3x plus c2 e to the negative x plus 1/4 x e to the 3x. Alright, let me stop for a minute. the fundamental thing to get from what we just did, I can't remember if I've said this way yet. My YPs have to also be linearly independent from these dudes. Because if they're not, they're gonna make it 0. They're not gonna make this happen. The job of YP is to make that happen. The job of these guys is to get out of that guy's way, to make it 0. Does that make sense when I say that? Okay. All right. So does everybody agree, whatever YP is, it must be linearly independent from either of these? I like it. Okay, okay. Somehow that's going to tie into today's new stuff.
I know it's
We
extra
get
work technically, but can it just be a to the x squared then too, if we really wanted to?
Say again, sorry?
Like, I know it's like extra work, but can it just technically be like a to the x squared if we wanted, like a to the x squared plus ax times e to the 3x? And-
Oh, so if you did like ax squared e to the 3x plus bx e to the 3x?
Yeah, kind of, where you just, I know it's more work, but can it be?
Yeah,
like, or-
sure, that would work.
Okay.
If you can throw in an infinite number, they'll just all come out to be 0 eventually, right? When you're actually done with all the work you just made for yourself.
Mhm.
Yeah, okay. But that'll happen with partial fractions. If you have too many things, it'll just come out to be 0 in the wash, right?
Mhm.
If you don't have enough things, that's where you're screwed. If you're missing something that's supposed to be there, you're screwed. You're gonna get to something that doesn't make any sense. 0 equals 1, you're gonna stare at your paper like, what have I done? Okay, don't use purple, Jeff. Good work. All right, is that okay?
This was us going over, 4.4.
This is 4.4. Yes, where we assume the form. We assume the form of the answer based on what's here, right? And again, does any function here work? Could this be any function? Could somebody give me an example of a function here that would not work for this process? Cotangent. Yeah. And again, real quick, how do you determine very quickly if whatever function's here, if it's not directly related to its own derivatives, right? So cosine's fine because cosine x becomes negative sine x becomes negative cosine x, so it's directly related to part of it. So it would be, I would assume for sine x, I would assume a sine x plus b cosine x. That would be related to the derivatives of what's there. Does that make sense? Why is this one something so simple, except for that guy? But because it's just an exponential, it's its own derivative. So cotangent, what's the derivative of cotangent? Negative cosecant squared. What's the derivative of negative cosecant squared? Bunch of shit, right? I'm getting further and further away from being related to the functions that were there. Does that make sense? So you don't have to memorize a list of functions. You can actually just memorize that fact. If the function that's there is related to its own derivatives, I'm allowed to do this process. You guys semi with me. So very quickly, just make really sure you understand what I mean, because it's not quite the full picture. But if I were to put, we're not going to do this problem, but if I were to put a sine x here, we would do blah, blah, blah. We do all the same shit we just did for the ox, the associated homogeneous. What would I assume the form of yp to be? Yeah, because the derivatives of these all are related to this. They all have that in them, right? Plus the derivatives have this in it. So there's a chance for this piece to cancel like it needs to, and there's a chance for this piece to stay alive like it needs to. Does that make sense? And when I have a function whose derivatives diverge from it continuously, just gets worse and worse and just brings in new things like cotangent does, it's not going to work with this. Okay, maybe. Okay. So, now, with the 10 minutes I got left, oh my God. I'm seriously got a petition to do a DE class in like 1 day a week. Would that suck or would that be?
1 day a week.
Yes. Dear God.
Just 3 hour long.
Yes. Yes. Because then if you introduce the topic, do enough examples, do some concrete shit, and then maybe even introduce one more time. It would be amazing.
That would be fun.
I'll stop talking because Jeff, you're making the problem worse. So, just to remind you guys, what I'm about to do, see how far I get. I want to show you the derivation of the process we use. You do not have to copy this down. You just watch, right? We pray Jeff doesn't miss something that he's written down for himself. Okay, so the idea behind this is if I have one of these suckers here. And I get, and this is not nice, right? Nice in terms of it will work with the section 4 ideas. Everybody with me? We'll call those nice. So like cosecant or cotangent or 1 over the square root of 1 minus x squared or all kinds of weird ass shit can be there. Here's what's so cool. So let's say that we set up the Jeff, not alcoholics anonymous. If we set up the we do the ox, blah blah blah, and we get this. So for this case, we can go to the second. Everything we're about to do can be expanded to be a higher order DE relatively simply. Okay. So far so good, right? Let's say that in this, and again, in this case, the function is one, I can't do the other, so there's nothing I can do right now. I can't do shit, so we have to develop something. Why did reduction of order work? Because I know that the second answer must be linearly independent to the first answer, therefore I know y2 must equal u, y1, for example. So everybody with me? We also just discussed the answers to yp. Not only do they have to be linearly independent to each other, they have to be linearly independent to
The general solutions?
yeah, these guys. Right? I think the book calls this the complementary. That's why there's a C there, but I always forget that. Remember, we just figured it out earlier, right? With the e to the 3x problem we did. If I didn't introduce an x, it would just make the function 0. It would never work. I could never figure out yp. So I know that whatever the answers are here, they have to be independent from each other, and they also must be independent from these. Okay. So what I'm going to do is I'm going to assume that yp is not only some functional coefficient related to y1, but it's also some functional coefficient of y2. Then will it be linearly independent from both of these? You guys agree? Okay. Oh, I love it. You're all like, I don't want to answer because maybe I'll stop. Okay. So now if I do yp prime, I'm going to get u1 prime y1 plus u1 y1 prime, right? Plus u2 prime y2 plus u2 y2 prime. Stay with me, stay with me. I love it. Most of you guys are not writing this down. That's good. All right, you don't have to. Then I gotta do y double prime. So I'm gonna get u1 double prime y1 plus u1 prime y1 prime, but that's also what I'm gonna get there. Let me just write them down separately just because. Plus u2, and here's the funny thing about when I get to the u2s. Isn't the u2 shift exactly the same as this, just the 2's instead of 1's? So I'm gonna get the same stuff. I'm gonna get this, plus this, plus, oh, I forgot one more, didn't I? Or little dude. Plus, u1, y1, plus this again, plus this. Right, I can already feel you guys letting go. All right, stay with me. Again, this is the derivation of a process we're going to use, right? Okay. Now, if I collect some stuff together, actually, I got to throw it in. That's right. So let's throw it into this thing. See how far I can make it. Let's see.
You have the left board too.
Is it good?
Scoot over that board too.
Oh, I could. Yeah, I wish I had all the way around the room. Well, I got some in the back. I could do that someday. So I've got U1 double, let me do this, just in the interest of time. If I threw all that shit in there, I'm not gonna write all that down. If I threw all that stuff in there and I try to collect some stuff together, some like term kind of stuff, I'm gonna end up here. Let's see, where am I at? Okay, there it is. I can get a bunch of stuff that has U1 in it. And this is, again, I collect all my stuff together. And then I'm gonna get a bunch of stuff that has U2 in it, which is not surprising. Really quickly, the stuff I just wrote, what is that equal to? Y1 and Y2 came from where? I know I erased this.
Zero.
Y1 and Y2 were this here, right? So what do they do? When you plug them into here, when you plug them into here, they're the YCs, right?
Zero.
They make it 0. That's 0. That's 0. Where did Y1 and Y2 come from? They came from the associated homogeneous. When I plug them in, I get 0. This is what I would get if I plug Y1 in, 0. This is what I get if I plug Y2 in, 0. Kick ass. This happened with reduction of order. Everybody notice this is like another layer of reduction of order, sort of? Okay, but the new thing here is we're not building YP off of one part of YP, we're building YP off of these guys. But the idea remains the same. I know they have to be linearly independent. So that's why this kind of makes sense to do. All right, so you also get, where am I at? Okay. Y1 U double prime, 1. What has he done, Jeff? Okay. Plus U1 prime, Y1 prime. And then another one. Wait a minute, I'm going to collect that at the end. Y2 U2 double prime. Plus U2 prime, Y2 prime. Plus Y1 prime, U1 prime. Oh, this is so exciting. Plus Y2. Let's see, where am I at? Yeah. Y2, U2 prime. Oh, this is so awesome, Jeff. I love it. Okay, now, let me not put that there because that all went to 0 anyway. Look at this piece right there. This might not be, well, let me just say, this is not immediately obvious, but do you guys see how that's a total derivative or something? That's like that. Yeah. So this is d by dx of y1 u1 prime. If I took this guy's derivative, what would I get? I would get y1 u1 double prime plus y1 prime u1 prime. Yes? Okay. Can I do the same thing with this?
Yes.
Yeah, so I get y2 u2 prime, right? Is everybody with me? Okay. And then I get this weird little shit on the outside. These poor little guys that went with nobody. I'm sorry, little guys. Did I forget a? I probably did. Poor little dude. Yes, I did. Don't worry about the specifics. Just, I think you all can appreciate it. If I organize my shit, I would get here. And then I organize it a little bit more, I get here. Let me organize it a little bit more. That's just, math is not awesome enough yet. Let's throw in organization on top of it. So everybody with me, I just put those together. Is that cool? Because derivatives are linear, so I can just throw those together. All right, now. By the way, this equals what? G of x. Okay, now. I know I'm over. I'm always over. And you guys are like, God damn this guy. Real quick, now watch. This is the important part, and I'm so sorry, but I'm not. Okay. This part kicks so much ass, and I'm going to pick up again next time, but I know that listen, I can assume, this is the part that's so nifty. This part right here, I did leave off some stuff, didn't I? Damn it. Oh yeah, that's true, I did. That's too bad. Let me go with this. There's one part I left off this one. If I assume this part to be 0, I can do that. I can actually assume this to be any anything I want to. Because all that would mean is, if I assume this to be 1, or x, the derivative would be 1, correct? And then I would subtract 1 from this side, and then this would equal g of x minus 1. I can assume this to be anything I want to. That feels like cheating, but again, we're just trying to figure out a u and a u1 and a u2 that will work. I can make any assumption I want to here. So if I assume that y1 u1 prime plus y2 u2 prime equals 0, and I also, and how many unknowns do I have? Here's the word, how many unknowns do I have in here?
3.
What are they? 2. What are they?
It's y1 and y2 though.
u1 prime and u2 prime, correct? y1 and y2 are not unknowns.
Correct.
So I need how many equations with 2 unknowns? 2. So now I've got this one. y1 prime u1 prime plus y2 prime u2 prime equals g of x. Okay, that's plenty, I'm sorry. So we'll pick up next time. I'm going to remind you about something called Cramer's rule. And that's going to finish this off so we can see what the hell the process is. Kramer, C-R-A-M-E-R. Kramer. Yeah, not Kramer versus Kramer.